Good morning, everyone. Sorry I'm not back today. I should be back tomorrow. Just needed to take another day. They had to do a little bit more in the surgery than they had anticipated. So, still in a little bit of pain. Actually, a lot of pain. So, sorry, another video. But I'll be back tomorrow for the tougher one. Okay. I do have your quizzes graded. They are up online. For those of you that were here. Okay. Make sure those of you that were not here to take the quiz, you'll be taking it as soon as I get back. There were a lot of 100s, okay, and people did really, really well. So thank you for helping each other out. I appreciate it. Hopefully you guys will continue to do the same today. Okay. All right, so we're going to add on to that angle sheet, the identity sheet, and it's actually the last new identities that you guys are going to learn. So the first one is called the cosine double angle identity. And the cosine double angle identity equals the following. Okay, so we're just going to go ahead and prove that real quick. So we're going to say that theta plus theta equals 2 theta. Okay, so as we write that out, it's going to be cosine of theta plus theta. And then we're going to use our cosine sum identity, which was what you guys were quizzed on. So cosine theta. Remember, it's the opposite sign, sine theta, sine theta. So you will see that the cosine double angle equals cosine squared minus sine squared. Okay. So that's one variation of it. Okay. All right, so now we're going to take the cosine double angle again, and we're going to prove that it equals 2 cosine squared theta minus 1. Okay, so from above, we already know that the cosine double angle equals cosine squared theta minus sine squared theta. Okay, and then we're going to use the Pythagorean identity. So notice that everything is in terms of cosine on the right-hand side. So I want to switch everything that's sine, if I can, to cosine, which I can use the Pythagorean identity. So cosine squared theta minus 1 minus cosine squared theta. Why is that possible? Because sine squared plus cosine squared equals 1. And then we can subtract cosine squared. Now, on your guys' verification, I wasn't super picky about it on the quiz due to the fact that I haven't been here, but I will be on the test, okay? So you guys need to make sure, you got to assume that I know nothing. So off to the side, you need to do this work, okay? I didn't take off points for it on the quiz, because like I said, I wasn't there to stress it enough, but even though I'm stressing it on the video again, you have to show all of your work. All right, and then we're going to distribute the negative through. And you will see that you get 2 cosine squared theta minus 1. So this is another variation of the cosine double angle. Okay. Also in your verification, make sure that you guys include an angle. So a lot of people I just saw like this, sine plus cosine equals 1. You guys need to make sure that you're plugging in a variable for that. All right, the last one we need to prove is that the cosine double angle equals 1 minus 2 cosine squared. Okay, once again, we're going to use a Pythagorean identity. Okay, and actually, sorry, this is a mistake. This should be 1 minus 2 sine squared theta. That's the other variation. Okay? All right, so now we see that everything's in terms of sine. So when we use the Pythagorean identity, we're going to want to sub out the cosine. Okay, so off to the side, we know that sine squared plus cosine squared equals 1. And if I want to get everything in terms of sine this time, then sine squared, To do that, we want to isolate the cosines here. So cosine squared equals 1 minus sine squared. Okay, so we're going to replace the cosine squared with what we just did to the right. So we get 1 minus sine squared theta minus sine squared theta. Combine like terms, you get 1 minus 2 sine squared theta. So that is the third and final variation of the cosine double angle. So you have 3 cosine double angles to remember. Nice thing is, for the sine double angle, there's only one. So we're going to apply our sum identity. So sine of theta plus theta. So we're going to do sine theta, cosine theta. Remember that if it's addition in the identity, it's addition when we expand it out. And then sine theta, cosine theta. Combine like terms, and you get 2 sine theta, cosine theta. Okay, so you will see that this is the sine double angle, and there we go. So you have 3 cosine double angles to memorize and then 1 sine double angle. And then we have one more identity on the next page. This is going to be for the tangent double angle identity. So we're going to apply our tangent sum identity. So we're going to do theta plus theta. So if we expanded this out using the identities that we already know, we would get the following. Okay, and then let's clean it up a little bit. On top we can combine like terms, so 2 tangent theta. And then in the denominator we get 1 minus tangent squared theta. Okay, so here is another identity, and notice that it's the same up here. Okay, so yay, those are the last identities that you need to memorize. No more. Well, unless you have first ones to memorize that you still don't have down yet. But most of you guys did really well in that section. All right, so now we're going to do example problems. So given that cosecant equals 3, we know that the ratio is going to be r over y. So theta is in quadrant 2, so that means the signs are negative, positive. We know what y is, it's going to be 1. We don't know what x is, and r is going to be 3. So this is not a Pythagorean triple, so I'm going to have to use the fact that x squared plus y squared equals r squared to find x. So 1 squared plus x squared equals 3 squared. We subtract the 1 from both sides, and we get x equal plus or minus 2 root 2. Okay? Now, most of us did a really good job on this on the quiz, but some of us still got caught up on not paying attention to what quadrant you're in when you were completing the Pythagorean triple. So since we're in quadrant 2, that means x has to be negative. So this is negative 2 root 2. Okay, so please, 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 please pay attention to which quadrant you're working in. All right, now that we have all of the information, we can go ahead and start practicing the double angle identities. Now for cosine double angle, you can use either one. You can use, actually either 3. Cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. It doesn't matter which one you use. Okay, I preferably just like cosine squared minus sine squared, but like I said, it doesn't matter. So we have cosine squared, which is going to be negative 2 root 2 over 3 squared minus sine squared. So we have 1 over 3 squared. Okay, so when we do the math, remember that when you square negative becomes a positive. Okay, and 2 root 2 squared is just 8. So this is 8 over 9 minus 1 over 9. So I get 7/9 as my answer. Okay. If you're not sure how we got 2 root 2 squared to be 8, remember that over here, the square root of 8 was 2 root 2. So if we square that, then it's going to go back to 8. If you would have chosen either one of the other cosine double angle identities, you would have gotten the same answer. Okay, so for the sine double angle, there's only one of them. It's 2 sine theta cosine theta. So we get 2 times the sine of theta, which is 1/3, times the cosine of theta, which is 2 root 2 over 3. So my final answer, remember that when you multiply fractions, you multiply straight across. You do not need a common denominator. So -4 root 2 over 9. Okay. All right. Moving on to the tangent double angle. Okay, this is typically just like it was for the sum and difference one. This one tends to be a tougher one for us. So let's first write it out. So we have 2 tangent theta over 1 minus tangent squared theta. So 2 tangent theta, well, tangent is going to be 1 over -2 root 2. Okay, and then the denominator, it's going to be 1 minus -1 over 2 root 2 squared. So we get -1 over root 2. The 2's are going to cancel. And then this is going to be 1 minus 1/8. Remember that when you square a negative, it becomes a positive. Also, 2 root 2 squared is 8. So then we have -1 over root 2. If you get a common denominator over here, this is going to be 8 over 8 minus 1/8, which is 7/8. And then finally, when you multiply fractions, you remember that you multiply by the reciprocal of the second fraction. So -1 over root 2 times 8 over 7. So this gives me -8 over 7 root 2. Okay, you do not need to rationalize. You can leave your answer like that. Okay, so all we did on these 3 problems, guys, is just apply the identities. That's all we had to do. Okay. All right, moving on. The last problem that we're going to do for up here is going to be the cosine squared plus sine squared. Now, hopefully that should ring a bell to you guys, that that's a Pythagorean identity. And we should know that that equals 1. So once we go through this and do the math, if it doesn't equal 1, we made a mistake somewhere. So cosine squared, -2 root 2 over 3 squared, plus 1/3 squared. That gives me 8 over 9, plus 1 over 9. So 9 over 9 equals 1. So we know that we did our correct math when finding x, y, and r. All right, moving along. So now you will notice that in these 3 examples, the identity has already been applied. It's been expanded out. So we need to work backwards. So first we have to recognize what type of double angle identity it is, and then go from there. So if you see 2 sine cosine, hopefully you're thinking that it's the sine double angle. Okay? Because the sine double angle is 2 sine theta cosine theta. Okay? But remember that equals sine of 2 times theta. That's a big mistake that we make here. So we have sine of 2 times the angle. So we get sine of pi over 4, and then actually find sine of pi over 4. Evaluate it, and you get root 2 over 2. Okay, so a couple things about this problem. Remember, it's a double angle identity, so we have to double the angle that was given to us. Okay, Once you get that angle, you get sine of pi over 4, which should be on the unit circle. So if you notice, if we would have multiplied by 2, we just would have had pi over 8. That's not on the unit circle. So when doing these problems, you should always get back onto the unit circle, which is a really good active note. Okay, and then once you get here, actually evaluate it. What's the coordinates? What is sine of pi over 4? Okay, on the quiz, a lot of you guys did this with tangent, but then you left it here. Take it one step further. All right, next example. Okay, so notice on this one, this one's a little tricky due to the fact that it's sine squared minus cosine squared, and we don't have any identities like that. Okay, but if I rewrite this as negative cosine squared of pi over 12 plus sine squared of pi over 12, I can take out a negative. Okay, now I have the cosine double angle inside. So we have negative cosine of 2 times pi over 12. Once again, if you didn't multiply that pi over 12 by 2, you wouldn't be on the unit circle. An active note, you should get back on the unit circle. So this is negative cosine of pi over 6. Now, a mistake that a lot of us made on the quiz here is that the cosine negative angle identity only applies when the actual angle is negative. Okay, so this cosine is negative, not the angle. So a lot of you dropped that and said it was positive, but you need to keep the negative. If negative's on the outside of cosine, it stays there. The only time we hypothetically drop it is when the angle, which is on the inside, is negative. So we get negative cosine of pi over 6, which is root 3 over 2. So there's our answer. All right, and last example on this page. This is a tricky one because at the moment it doesn't look like there's any type of identity. So just like on the problem before, we have to do some preliminary work. We want this to be a 1 and a 2. That's what the identity is for the cosine double angle. So I'm going to take out a 6, and then I'm left with 1 minus 2 sine squared of 7 pi over 12. Okay. Now I have the cosine double angle. Okay, this equals cosine double angle. So I have 6 times cosine of 2 times 7 pi over 12. So that's 6 times the cosine of 7 pi over 6. Okay, remember that when you get here, make sure you actually do the angle. So cosine of 7 pi over 6 is going to be negative root 3 over 2. Multiply straight across, and we get negative 3 root 3. Okay. So when any of these types of problems where you're working backwards, remember that you should be on the unit circle by the time you're done. Okay, and then after you're on the unit circle, make sure you actually apply the angle. All right, next page and last page for this video. Okay, so here's another example of working backwards. So this one, the tangent double angle has already been written out for you. Okay, so you have to work backwards. Sometimes students get this one confused with the sum and difference identity for tangent. Well, notice that this one is squared. If you're squaring anything in tangent, then it's going to be the double angle. So we're just going to work backwards. So tangent of 2 times 7 pi over 8 gives me tangent of 7 pi over 4. Notice that multiplying by 2 got us back onto the unit circle. And then 7 pi over 4 is in quadrant 4, so that's negative 1. All right, we are going to skip number 6. Woohoo! And let's go to number 7. So number 7 is asking us now to solve, okay? We can't factor a sign out here, okay? Sine of 2x is not the same thing as sine x plus sine x, okay? We proved that a couple lessons ago. So instead, we have to think about, are there any identities that I can apply? And yes, we can apply the sine double angle here. So 2 sine x cosine x minus cosine x equals 0. Now you can factor because they are all single angles. Okay, so we don't want to be factoring unless we're working with single angles. So I can take a cosine x out, and I'm left with 2 sine x minus 1. Set each one equal to 0. Okay. Solve for the trig function, and then find the angles that make it true. So cosine x is going to be 0 at pi over 2 and then 3 pi over 2. And then sine equals 1/2 at pi over 6 and 5 pi over 6. Okay. Now if you can, it is appreciated for you to write these in numerical order. So it would go pi over 6, pi over 2, 5 pi over 6, 3 pi over 2. Okay. Hopefully you notice that we just keep building on top of what we already have. So you guys have already been practicing solving. You've already been practicing factoring with solving, and then we added on using the double angle identity first. All right, 2 problems left. Hopefully we noticed that the verification problems on the quiz were very similar to the ones that I had you guys do for that check-in. I appreciate those of you that went back and actually looked at my feedback because I did provide a lot. Okay, so if you haven't done so, I would do that. And then, of course, we'll obviously do quiz corrections before the test. All right, so this one can be kind of tough on where to go, and sometimes you're going to try something and it's not going to work, and you have to erase it, and you're going to have to try a different identity all over again. Okay, so first of all, nice thing is that this only has one option. This is 2 sine beta cosine beta. Okay. By the way, you should be writing left-hand side on your, quizzes and tests. A lot of you didn't. Okay, you need to show that you're working with the left-hand side and you're trying to go to the right-hand side. Okay, now the question becomes here, which identity do I use for cosine 2 beta? Okay, because there's 3 different ones I can choose. Okay, it doesn't matter. Okay, I'm just going to do 1 minus 2 cosine squared beta minus 1, and this is all in parentheses. The reason why I did that is because I'm going to be able to get a Pythagorean identity out of this. So we have 2 sine beta cosine beta all over 1 minus 2 cosine squared beta plus 1. Make sure that you distribute that negative through to everything. So let's go ahead and clean this up a little by combining like terms. Okay. And then notice there's a lot of 2's going on, so I'm going to see if I can factor a 2 out of that denominator so that it'll cancel. Okay. And nicely it does. So now we're down to sine beta, cosine beta, and then 1 minus cosine squared beta, which hopefully is ringing a bell, a Pythagorean identity. So we have sine beta, cosine beta, all over sine squared beta. Okay, now make sure, a lot of you guys didn't do this on the quiz either, make sure that you're showing that something is canceling. So show that sine beta cancels and then just the squared cancels, okay? If you put a big dash through both signs, then technically you're trying to say that everything is canceling, and it's not if the ratio isn't 1 to 1. Okay, and so we get cosine beta over sine of beta, and that equals exactly what the right-hand side stated. Okay. I know that's a lot of work. Okay, you definitely will not be having any type of verification longer than this at all. Okay, most of your verifications are only going to be a few steps. Okay, last problem. Okay, we have to verify this. Remember that when you are taking a quantity squared, you have to expand it out. Okay, I actually wrote that on a question in that help discussion. -1, and then we're working with the left-hand side. So we're going to FOIL this. Okay. And hopefully we recognize that there's a Pythagorean identity in here. Sine squared plus cosine squared equals 1. So now we have 1 plus 2 sine x cosine x minus 1. The 1's are going to cancel, and I'm left with 2 sine x cosine x, which is what the double angle identity is for sine. So sine 2x equals sine 2x. Okay, now that we're working with double angle identities, make sure that your 2's are for the double angle and they don't look like they're being squared. Okay, so there's a difference between sine squared x and sine 2x. Okay, so make sure that your handwriting, I can tell the difference. Once again, if you guys want to take pictures of problems that you've tried but you're still stuck on, go ahead and post them to the help discussion on Schoology. I will take a look at them tonight or throughout the day if you guys are posting throughout the day, and then I'll answer them, and then I will see you guys tomorrow. Okay? Please help each other out. Again, like I said, the answer key, I don't have it prepared since I wasn't planning on not being here today, but it is on Schoology. So it won't be on the podium, but it is on Schoology. Okay? Hope you guys have a wonderful day, and see you tomorrow. Thank you.